At first, raise your hands who are writing tests, Autotests. Okay, a lot, nice. What about unit tests? Cool. Integration? Amazing. End-to-end, yeah, bunch of hands, yeah. Okay. So I think it will be beneficial and useful. In this talk, we will deep dive into 3 cases. I will show you 3 cases. Why sometimes Autotest passes, even the code fails. Or the production fails, it doesn't matter. And 4 tips, how can you improve that? I already asked that one. So first case, you write a code, write a test passes, everything is good and fine, production is failing. So what's going on here? Bug in the code and bug in the test. And it was 9 years ago, I think. Yeah, I'm that old. And it was a one-liner. And I remember it was like yesterday. A developer came to me and said, Gintarė, I have a small fix. It is one-liner, just a file name change. I wrote a test for that. It's a unit test. Everything looks good and fine. And what that developer didn't mention that he copied and pasted the file name from the code to the test. So yeah, the test is passing. And that file and that change of code was missing a dot. And actually, the production was crashing. Another one is missing asserts. Who has encountered that one in the test without any assert? Just a couple of hands? Nice. Lucky bastards. Sorry for that. So yeah, I have been working in a couple of companies, and this is the one. Basically, the test should test that, yeah, user can log in and log out successfully. And it was good and fine, and the test was missing an insert, and the application actually crashed out of login. Also have a kind of, not that recent, it was 3 years ago. Then I log out from the bank system, and it was also crashing. And let's deep dive into the second case. We're writing code, writing test passes, all good and fine, production is okay, all good and fine. Change code, test passes again, everything is fine, and the production fails. What's going on here? So, bug in the test and at the first place, and bug in the change code. So what is going on here? So when the test is asserting the wrong thing, well, actually checking the wrong thing. And it was like a few weeks ago, I think. We had a test that checks if switching VPN protocols where we are still connected to the VPN. And it was all good and fine. We are selecting VPN protocol, connecting to the VPN, checking that it's working, changing the protocol, checking the VPN is working. But what was missed, we never checked the protocol switch itself. And there was a bug that then you switch one protocol to another, it came back to the previous one. And missing awaits in the async await code. It looks good on paper, but it's the same as, let's say you're in a busy parking lot. You're in a hurry, you close the door of your car, and you left. Yeah, it looks good on paper, but it's not locked. So it's the same with the test. It looks good on paper, but it just passes. And expect whenever it can. And And another one, asserting the loop. So basically, then you're checking the list, and you're assuming that you have some values in that, and you are just asserting what those values are. But let's say, what if the list itself is empty? The test is passed. It was the same that we tested an API call with currencies. And we checked that all currencies are in a particular order and they are all the same, blah, blah, blah. But we never test the list itself, but it has at least one element, at least something. So the test passed and the drop-down is empty. And let's move to the last case for today. So writing a code, writing a test fails, production is okay. Bug in test, apparently. Yeah, so copy-paste again. This is from the end-to-end test. The test itself looks kind of okay. Yeah, we are inserting an email field, the password field, clicking login. But what was done under the hood? So basically, we copied ID 2 times. So the email field got entered 2 times. And that's why the test failed, sorry. And another one is by sharing the application or user state, then the tests are changing the state. So it's all good, looks good and fine, and the tests are running one by one. But then you turn on parallel, you can get a flaky test, you can get a failed test, because one test is changing the same user state that the other is expecting. So once I remember that we had a user that was a read-only one, and we checked the data that is still present. I think it was not written down that that user is read-only, nothing whatsoever. And after half a year, the test was written that changed the user's name. So one test was checking that the user is Jane Doe, and another changed the username to Mark. And then we ran the test in parallel. It was a flaky test because sometimes it was Mark, sometimes it was Jane Doe. So who guards the guardian? Who tests our test? Surprise, surprise, it is us. Now it will be four tips that you can take away if you want. So first and foremost, know the framework you are working. Deep dive into the documentation if you need, just know its peculiarities and how to work with that one efficiently. The next one, embrace design patterns. Because Autotests are also a code, and they deserve to be treated as one, as like Vic's jumpers there. So this is an example. One test is written without any design patterns whatsoever, and another uses a couple of them. It's all the same, but just the bunch of that, it's just 2 liners. The next one is dedicating for running for end-to-end test. Before merging to the main branch, run the test 3-5 times in a row and check that it passes every single time. Sometimes it sounds easier than it's done. Sometimes not. But that's how we can escape all the flakiness, and we can rely on them more. And the last one, fail the test on purpose. I love this one. It's even by removing the lines from the test itself, like it was done, the test should fail, or by changing the asserts value. Here we are checking that some toggle is on, just change the assert off and check if that fails. because it should. And the last one, change the code itself without changing the test. So mutate the code. And the test should fail also, because it should catch changes in the code. So do we really need to do all this by hand? In most cases, yes. But for those who write unit tests or integration tests, you are the luckiest one. Because we have mutation testing. And it's basically dedicated for unit testing. I read some articles that you can also use in end-to-end tests, checking them. And what it does, it shows the quality of your test. It shows if you are missing some, that you can improve some, and if they are really testing what you think they are. Checking. So how it works and what it does. You have a code, and the mutation testing tool just change the code, code, injects the flaws or mutants into the code and runs tests. And it's a bit of vice versa. So if the test is passing, that means mutant is alive, and that's bad, because it didn't caught the change. And if the test is failing, so that means mutant is killed, and surprise, surprise, you caught the change. So how it looks like in the code itself. Let's imagine that we are in the club, and near the club there is a scanner, and it allows the clients that are 18 or older. So what the mutant can do to that code, it can allow the users only that are older than 18. It can allow users that are younger than 18. It can just shut down and do not allow anyone, and can allow everyone, even toddlers. And this is from Striker. It's one of the tools that you can use for JavaScript, TypeScript, Scala, and C#. I took a simple example with a calculator. So we have 3 functions, and we wrote some tests for that. Keep in mind of that test cases. You will need it later, but I will say the differences. So everything looks good and fine, yeah? All test passes, the code coverage looks good. Let's run Striker for that. So it generated 6 mutants, and 3 of them were killed and 3 survived. So the killed ones, we can see that all the code block was removed, and the test means they failed, and they caught the changes. But for the survived ones, they changed the arithmetic symbol, so from plus to minus, from minus to plus, and vice versa. And those were not caught. So what our tests are testing, after all? So how can we improve them? Basically by improving the test cases itself, making it more, how to say? I don't know. With an example. At first we had 100, 0, and 100. So it's mean 100 plus 0 equals 100. It's the same, yeah? So just make it a little bit different. And now run the Striker, and all mutants are killed. So this is an example how we can improve our Autotests. And there are some available tools for different programming languages. I just will mention a couple of them. So Pit for Java, Mut for Python, Striker mentioned that already, Infection for PHP, Mutant for Ruby. And this Mutant for Ruby, it's actually for the companies, it costs. The rest are open source ones. And there are many more. Just keep in mind some things. One of them is performance. And Imagine that you have 500 classes, 20 unit tests per class, and 1 millisecond per unit test. So the test run is 10 seconds. And let's say now we add 10 mutants per class. So with no configuration whatsoever, brute force, the test run will take 13 hours, 53 minutes, and 20 seconds. So for instance, once I worked with a Python project and I used mut for that, it generated 8,000 mutants, and it took me 2.5 days to run all that. So it was 24-hour run. I left my computer on weekend. Wow, that was fast. So the last thing I want to say, all these frameworks, all these tools, all these principles and design patterns, also here for us just to help us to improve our Autotests, because after all, they are just a code too. Thank you.